So next, continuing with the chapter 6. So law of convection, that is your Newton's law of cooling. It states that the rate of heat transfer per unit area is directly proportional to the temperature difference between solid and fluid. So mathematically we can write. So if I saw in your diagram, so you can see that. So this is a suppose solid surface having temperature Ts, and if the air is flow over this solid surface, when the air is in motion with the solid surface, the air having temperature suppose T infinity, then what will happen? So if I draw, so when it will be passed through the surface, the temperature of the will be gradually decreases of the solid surface. So, and the temperature of T infinity will be increases. Why? Because it will carry the heat from the hot surface. That is your solid surface is your hot surface. Suppose solid surface is your hot surface. So it will be carry the heat. Air will be carry the heat from the hot surface and it become more hotter. It become heated. Air will be heated and the solid surface will be temperature will be decreases. So Q by mathematical if I write Q by A is directly proportional to temperature difference between solid surface and the fluid medium, that is T infinite, Ts minus T infinite. So Q by A is equal to H Ts minus T infinite. What is H? H is your convective heat transfer coefficient, and that will be watt per unit is watt per meter square degree centigrade or watt per meter square Kelvin. And the more the motion of the fluid, more will be the convective heat transfer. Then radiation. What is radiation? Follow the law, that is Stephen-Boltzmann law. It said that the rate of heat transfer per unit area of a block body is directly proportional to the fourth power of absolute temperature. So Q by A is directly proportional to T to the power 4. So Q by A is equal to F sigma T to the power 4. So Q is equal to AF sigma T to the power 4. So what is your F? F is your factor depend upon the geometry or surface properties. So F is equal to 1 for what? If the black body cover with another surface. And F is equal to emissivity for what? For other than black body. So if I write, this is a rate of heat transfer per unit area of a black body. So for a black body, what is F? F is equal to 1. So we can write Q is equal to A sigma T to the power 4. So rate of heat transfer for black body is Q is equal to A sigma T to the power 4. Only for which body? Only for black body. This is only for black body. If you consider your other than black body, then what will that? Q is equal to A. In plus of F, we can write emissivity sigma T to the power 4. This is for other than black body. You can write this is for other than black body. Other than black body. So you have to find out the heat transfer. Then Q is equal to A sigma T. What is sigma? Sigma is a Stephen-Boltzmann constant, that is unit, that constant value is 5.67 in 10 to the power minus 8 watt per meter square Kelvin to the power 4. So that is the value of sigma. Next we will discuss, these are the three laws of conduction, convection and radiation. Next we will discuss black body radiation. What is black body? Black body is the body which absorbs all the incident radiation from the all direction or from all wavelength. So at any temperature and wavelength, nobody can emit energy more than black body. Although the radiation emitted by the black body depend upon the wavelength and temperature, but it will be independent of direction. The black body neither reflect nor transmit any amount of incident radiation, only it can absorb it. So absorptivity of black body is more, that will be. Then emissivity. What is emissivity? It is the ratio of radiation heat flux emitted by the real surface at a temperature T and over of wavelength into a hemispherical space to that which would be emitted by the black body at the same temperature. So what is emissivity? Ratio of radiation heat flux emitted by real surface to that of radiation emitted by the black body, E by EB. For real surface, for emissivity, E is equal to sigma E into B. What is EB? Sigma A T to the power 4. Okay. Emissive power per black body is your sigma A T to the power 4. What is emissivity epsilon? That is your emissivity, ability of material to radiate heat. So, radiation heat flux emitted by the real surface E is equal to what? E is equal to epsilon to indigo. What is the EB? That is your sigma T to the power 4. That is emissivity. Real surface by black body. Then absorptivity. What is absorptivity? A black body absorbs all the incident radiation from all wavelength. Hence, its absorptivity considered to be what? Unity. But real surface do not absorb all the incident radiation. So, what I can write? The total or average or hemispherical absorptivity alpha is defined as the fraction of radiation energy incident on the surface from all directions over entire wavelength spectrum, that is absorbed by the surface. So, what is alpha? Alpha is equal to Ga by G. So, what is energy absorbed by the surface divided by irradiation G. So, that is equal to what? That is your absorptivity. What is reflectivity? Defined as the fraction of radiation energy incident on the surface from the all direction over all wavelength which is reflected. Gr by G. That is your energy reflected by the surface Gr divided by irradiation. If the surface has some roughness, then incident radiation is scattered in the all direction after reflection. Such reflectivity is called diffuse reflection. Then we will go for transmissibility. Then when the radiation beam is incident on the semi-transparent surface and a part of is reflected and a part of absorbed and remaining is transferred. So that is known as what? Transmissibility. So if you see, suppose energy will become here. Sum of the energy, this is your G. So what will happen? Irradiation, sum of the energy will be absorbed. Sum of the energy will be absorbed, that is Ga. Sum of energy will be reflected, Gr. And sum of energy will be transmitted here. Okay. So the energy that will be absorbed, Ga by G, that is your absorptivity. Sum of the energy will be reflected, Gr by G, that is your known as your reflectivity, that is rho. And transmissibility, sum of the energy will be known as G tau by G, that is known as your tau, that is equal to what? Transmissibility. So, alpha, absorptivity, reflectivity and transmissibility is equal to what? 1. That is equal to 1. Then we will discuss what is Kirchhoff's law. State that at thermal equilibrium, ratio of spectral emissive power to the spectral absorptivity of all body must be constant. So, E epsilon 1 by alpha epsilon absorptivity. E means that is a spectrum emissive power, E epsilon 1 divided by spectral absorptivity, that is alpha lambda 1, that is equal to E lambda 2 by alpha lambda 2, that is equal to E lambda 3 of alpha lambda 3, that is equal to E lambda b by alpha lambda b, that is equal to constant. Emissivity by absorptivity. So, what is your alpha of absorptivity of black surface? Lambda means black surface of all wavelength, that is equal to 1. Then emissive power of all wavelength at 1 is equal to, so that is equal to basically E lambda 1 by alpha lambda 1 is equal to E lambda b by alpha lambda b. So what is your alpha lambda b? That is equal to 1. So we can write that E lambda 1 by E lambda b, that is equal to what? Alpha lambda 1. So we can say that what? E lambda 1 is equal to alpha lambda 1. Similarly, for other body, it can be shown that thermal equilibrium, the energy emitted by a surface must be equal to the energy absorbed by the surface. Energy emitted by the surface is equal to energy absorbed by the surface. The spectral emissivity is equal to 1 when spectrum absorptivity of the thermal equilibrium. Then this law is applicable when radiation properties are independent of wavelength. So it is another alpha lambda 1. So emissive power is equal to absorptivity. That is your what? That is your Kirchhoff's law. Thank you.